Welcome back to the course. So in this lecture, let's explore about another important C library function, scanf. So scanf is a standard library function that allows you to read input data from standard in. So standard in for us is generally the keyboard. If you are working on your personal computer, then usually standard in means the keyboard, right? So if it is embedded system, then it may not be keyboard. So it may be a touch screen or it may be a keypad like that. So by using scanf library function, so you can read both characters and numbers from the keyboard. Let's explore how to use this scanf. So now take a look into this code snippet here. So here that is a variable definition, age, and in this code, so you are actually asking user to enter the age. So now this is how the user data is read inside the program. Here, observe this part here. So here, whatever the user enters, usually the number, right? So that is actually put into the address of the variable. So what scanf does is, whatever the value you enter, it will be read from the input stream and it will be saved at the address of this variable. So that's the reason you have to mention the address operator here. So address of age. This is a format specifier. So in this case, scanf reads an integer, that is a number, which the user enters. And scanf puts the read value at the address of age variable. So now let's say I enter the number, let's say 8. So when I enter 8 from my keyboard, the number 8 is stored at the address of age, not its ASCII equivalent. So you have to remember that. Why? Because I have used the format specifier %d. So I want a number to be stored in the variable. So suppose if I use %c here, then its ASCII equivalent will be stored in this variable. So that is 56. So that's how you should differentiate. So what actually should be stored in the variable, you can decide that by using the format specifier. So here I want to store a character. So that means an ASCII value of the character into the variable. So in this case, I use %c. So suppose if I enter the letter A, then its ASCII value will be stored in the variable C. There is one more library function called getChar. This is also used to read input from the standard in. So if you just want to read a single character from the keyboard in ASCII format, then just use getChar. So its use is to read a character from the keyboard. So getChar function takes no argument and just returns an int value which happens to be the ASCII value of the key pressed. So for example, in this case, int a is equal to getChar. So here what happens is the program hangs until you press a key from your keyboard followed by pressing the enter key. So we'll see how to use these functions practically in the next lecture. So in the next lecture, so we'll be doing one exercise using scanf and other functions. So write a program which takes 3 numbers from the user, and the program should compute the average of those numbers and the result must be printed. And we'll see how to implement this exercise in the next lecture. Right, now let's create a new project. So here we are creating project for our PC, not for the embedded board. So C and C++ project. So now let me give the name average. Let me create new source file. Let me call main.c. First, let's create a variable. Let's create 3 variables. Let me create int number 1, number 2, and number 3. And after that, now let me first ask the user to enter the first number. So user may enter real number, right? So that is also possible. So that's why let's take float here instead of int. And now let me also create one more variable called float average to store the average value. Let me ask the user to enter the first number, enter the first number slash n, or let me not give slash n here. So let user enter after this colon. So I would just give this message, enter the first number. So cursor will not move to the next line, rather it will just stick at this position. After that, let me give the semicolon. All right, now let's use the scanf function, scanf. So now let's first mention the format specifier, that is %f. After that, let's give a comma, and after that, let's give the address of the first variable, number 1. So after that, let's repeat these two statements for the second number and for the third number. Let me change this to second. This is number 2 and this is number 3. Now after that, let's compute the average. Average is equal to, now let me keep all these things in a bracket, and let's divide the whole thing by 3, right? And after that, let's print the average, printf average. So here, just observe that this message will get printed right after this message, right? So because we didn't use slash n here. So what we can do is we can use slash n at the beginning of the second printf and here as well. It looks fine. And now let's try to build this project. It built successfully and let's run. So now here you can see that when you try to run the application, the average.exe ran, isn't it? So, but the first message is not getting printed. Now the reason for that is this message is actually not reaching to the console. So that means this message is actually buffered inside the operating system. So that is not pushed or flushed to the console. So problems like this you may encounter when you use different consoles. So here we are using console of an Eclipse software, right? So there may be a console buffering. When you execute printf, actually what happens is the content will not be pushed directly to the display. It is actually buffered inside the output buffer. So this is actually a software buffer. When your application returns, so the content of the output buffer will be automatically flushed to the display. So, but in our program, what's happening is we are waiting for the user input, right? So there is no trigger for the output buffer to flush the contents to the display. In the earlier program, we were returning from the function, right? So that's the reason. So there was a trigger to flush the contents of the output buffer to the display. So now here we have to give explicit command for the output buffer to flush the contents to the display. Now we do that by using a function called fflush. So fflush is actually an API which is used to clear the output buffers of the output stream. So when you use fflush, the contents of the output buffer will be flushed to the display. Let's use this fflush. So here, right after this line, I'm going to use fflush. Fflush stdout. So the argument what you have to pass here is stdout, that is standard output, flush to the standard output. Let me close this application. So here you can see that when I end that application, all the contents are automatically flushed, right? Let's try to build this project and let's see how this behaves. Right, so here you can see that now we are getting the message, right? Let's do this fflush right after every printf. So now let's see how this behaves. Now let me run this program. So enter the first number. Here you can see that this Eclipse console is not showing you the cursor. So that's a problem. So now you can click here. Let me type 3.5 and let's hit enter. Here you can see that it is actually showing the cursor here, right? So that is not correct. So now here, let's type the next number. Let me type 2.5. Enter the third number. So let's type 3. Let's hit enter. And here you can see that it is showing you the result, that is average is 3. That is actually correct, right? So this Eclipse console is not that great. So instead of using this, what you can do is You can directly execute this average.exe as Windows application. For that, what you have to do is go to its path, and in the resource tab, you can see this icon, right? So just click that and it will open you the project workspace. So go inside this, go inside debug, and you can directly launch this. All right, now let's launch this application. Just double click, and here you can see that this actually looks good because it is actually showing you the correct cursor position for you to enter the number, right? Let me enter some number, let's say 45, and then press enter, and then let me enter some other number. So now let me hit enter, and here you can see that the console is exited. We couldn't able to see the result, right? Now that's because, so in the program, after you print the average, this code exits, right? That's actually the completion of the application, right? So that's why the console exited. So we couldn't able to observe the result. Let's implement some logic in the program so that your program hangs after printing the result. For that, what we can do is, so we can make the application wait until user presses any key from the keyboard. So that means let's use getChar here. So let me use the getChar API. This API waits until user presses any key from the keyboard. So now let me just call getChar. So that means get a character from the keyboard. So until user enters a character, this API waits. Let's test this. Let's see whether our application waits for the user input or not before it exits. Let me launch once again. So no, it doesn't wait. So now we have to understand what exactly going on here. So it actually didn't wait here. Let's understand the relationship between the keyboard, input buffer, and the program. Now, whatever you enter from the keyboard, so it actually doesn't come to the program directly. It actually goes to the input buffer. For example, let's say we are actually scanning for the first number. Let's say you enter 10, and after that you hit enter, isn't it? So once you do that at the keyboard side, what happens is those two data will come to the input buffer. So now the input buffer has two different data. One is a number what you enter, that is 10, and another one is the new line character. So that is your enter key. So that is also stored in the input buffer. Once it comes to the input buffer, scanf actually reads the data. In this case, scanf should read one real number, right? So that is what our code, isn't it? So we want to read a real number. So that's why we specified the format specifier %f, isn't it? So this data will be read from the scanf. So we have instructed scanf just to read one data because there is only one format specifier, right? So once scanf reads that, this will be the state of the input buffer. So now /n is remaining in the input buffer. So that is actually an unread data, right? After that, you want to execute the second scanf, right? So once you make a call to the second scanf, what happens? So this /n, that is actually a special character. So this new line character will be read and discarded by the scanf because it's not a valid number, but a special character. So scanf actually waits for the new user input. And after that, let's say user enters a new number followed by the enter key. So scanf will read this number 45, and after that, let's say you execute the final scanf for the number 3. Let's say this time input buffer contain 65 and a new line character. So now 65 will be read by the scanf, right? And after that, this is the final state of the input buffer after 3 scanfs in the program. So that is the data which is still there in the input buffer, isn't it? After that, what we are doing in the program is we are calculating the average, and after that we are printing the average, and after that we are using getChar, right? So getChar, this time it doesn't wait for the user input because getChar goes and fetches whatever the data is there in the input buffer. So that's its behavior. Sorry, so that is actually /n. So getChar fetches /n and it returns. That's the behavior of the getChar. So whenever it encounters a new line character, the getChar returns immediately. So that is the behavior of that API. So that's why getChar actually fetches /n and it returns. So that's why our application didn't wait. So it exited immediately. How to solve this issue? One thing is you can give getChar twice here. So now you can solve this problem by giving getChar twice. So this is actually not a generic solution, but just to see the effect, you can give getChar twice here and you can give one message to the user saying press enter key to exit the application. Let's try. So now here you can see that the application is waiting because of that second getChar. And if you press enter, the getChar immediately returns. So now let me press enter key, and here you can see that the application exited. So as I said, this is not a generic solution. The generic solution looks something like this. What I would do is I would use a while loop here. Don't worry, so I have not yet covered while loop, so you will understand this code after I cover the looping in C. So what I would do is getChar is not is equal to, let's say, /n. Here I just loop here until I read every data from the input buffer. So after that, at the end, I again wait for the user input. Let me just test this. So this is the average. So you can cross-check this with your calculator and then press enter key to exit the application. So try to do this at your desk and let me know if you have any questions. And in the next lecture, let's use only one scanf to read all the three numbers instead of using three scanf functions. And I'll see you in the next lecture. So instead of using three scanf functions, now let's use only one scanf function. For that, I'm going to create one more source file here. So I will call it as main new.c. And after that, let me go to the main.c and let's just copy this code here. And after that, I'm going to exclude this file from the build. This is our old file, right? So what I would do is I would just right click on that file, select properties, go to C and C++ build. Here, just check this, exclude resource from build, apply, and close. So now let me just remove all these codes. So print, enter, let's say three numbers. So let's ask the user to enter three numbers. And after that, let's use scanf to read three numbers. So for that, we can use three format specifiers one by one. So here what I would do is %f space %f space %f. And after that, what I can do is number 1, number 2, and number 3. So here I have used three format specifiers. That means scanf will wait until you enter three numbers. And these codes will be same. So there is no change with the code. Let me just build this project and let's test. Enter three numbers. So now how do you enter the number? So first you enter the first number, then you can give space or you can hit enter or you can give a tab. So you can do whatever you want. The scanf will identify and it will read the three numbers. Now let me just close this and let's launch once again. So let me enter like this. 1, 2, 3, and after that I will give space. The second number, let me enter 90, and the third number. These are the three numbers. So it calculated the average. So it actually read those three numbers and calculated the average. Let's try in another format. Now let me enter like this. Let me enter some number, and instead of giving space, let me hit enter, and after that enter the next number. So this also works. Or what you can do is you can write the first number, then you can use tab. Let me give the tab. Right. So here actually I entered 5 numbers, right? But scanf will take only 3 numbers, remember. It will not take these 2 numbers. Let me hit enter, right? So here you can see that there is actually an accuracy issue, right? So the result should have been 0.2. So now to resolve this issue, so what you can do is you can convert this to double instead of float, because double actually has more precision than float, isn't it? So instead of float, we can use double here. Once you use double, you have to change this format specifier to LF. So that's a format specifier for the double. So now here let me use LF. Let me print only 3 numbers after the decimal point. So I would give 0.3. Hit enter, and here you can see that this is the average. Now actually the result is correct, right? So 241.2. So try this at your desk and let me know if you have any doubts, and I'll see you in the next lecture. Welcome back to the lecture. So I want you to do one exercise. So exercise is very simple. Write a program which takes 6 characters. So characters may be combination of alphabets, numbers, or special characters. The program should take 6 characters from the user and prints the ASCII codes of the entered characters. This is how your output should look like. So I have already written that code. So this is how your output should look like. So first there should be a message saying enter 6 characters of your choice. Let me enter A, B, C, D, 1 and 2. So just enter the input by giving space in between. All right, so when I hit enter, so it should print the ASCII codes, the equivalent ASCII codes of the characters. So I hope you can do this exercise, and I'll see you in the next lecture. So in the next lecture, let me implement this. So I just created a new project here, ASCII, and let me implement the previous exercise. First, let me use the printf to send the message to the user. And after that, let's use scanf to read the inputs. So scanf, so we are going to read 6 inputs, right? 6 characters. So the format specifier will be %C. Let me give space after one format specifier. Let me mention the second format specifier here. After that, let me write 6 times. Fair enough. And after that, let me create variables. Char, C1, C2, C3, C4, C5, and C6. Right, so these are the variables to hold those characters. Let me just give ampersand sign here. That looks good. And after that, let's print the ASCII codes. ASCII codes. So ASCII code is a number, right? So which format specifier you use to print a number? You can either use %D, that is for signed integers, or %U, right, if it is unsigned. So I can use %D or %U here, but I would use %U here because anyway the codes they are unsigned numbers, right? So let me repeat this 6 times. Let me give /n at the beginning, and after that let's print the value of these variables. That's it. Only 4 lines of code. So after that, what I would do is I will just go to my old project and I will copy this part, because this is required to halt our application, right? So now let me come here and let me just paste that. All right, so now let me give /n here. Let's try to build this code and let's test this. So enter any characters of your choice. Let me enter A space B space C D 1 and %sign. Let me hit enter. These are the ASCII codes of the entered characters. So this is the correct result. So I hope you did this exercise, and if you have any questions, let me know. And I would like to give another assignment to you. So modify this code. The output should be same, but instead of using scanf, use getchar. And if you want the solution, then you can just check the resource section of this lecture. So I have attached the solution and just take a look into that. So, but before that, try to do it yourself. So remove scanf and just use getCal function. And I'll see you in the next lecture.
So now let's do an exercise. Find out the number of electrons responsible for producing the given charge. Use scientific notation while inputting and outputting the numbers. So the equation is number of electrons is equal to given charge divided by charge of an electron. So now let's do this exercise. First of all, let me create some variables. Let me use the data type double to take the charge. Let's say charge. And after that, to take the charge of an electron, let me create one more variable, charge E. And after that, let me use printf to give the message, enter the charge. And after that, let's scan the number. For that, I'm going to use LF. For double, you have to use LF and of charge. And after that, printf, let me ask the user to enter the charge of an electron. And let me take this number in scientific notation. So for that, I'm going to use scanf percentage %LE and of charge E. And after that, let me calculate the number of electrons. For that, let me create one more variable, double electrons. So electrons is equal to the given charge divided by charge of single electron, and this would give you the negative result, and let me multiply it by -1. Fine, and after that let's print the result in scientific notation. Total number of electrons is equal to percentage %LE, and let's print electrons here. And also let me print in non-scientific notation. For that, let me use the LF. And let me just hang the application. So now let's see how this goes. Let me just compile this code and let me execute the binary as command line application. So now enter the charge. Let me type 0.005. Now enter the charge of an electron. So now you can input the number in scientific notation. So let me input -1.602 E -19. These are the outputs. So now the first output is in scientific notation and the second output is in non-scientific notation. So that's about usage of float and double data types in C, and we'll do more examples as we make a progress in this code. So I'll see you in the next lecture.